Namaskar, my dear friends. So, as we have been seeing LTSpice simulation trainings, so what we'll do in this session is we'll try to understand a lot of shortcuts that can be utilized, which can be very, very handy for your circuit designs. Okay. Anyway, these are not necessary, but these are very, very important. While utilizing LTSpice, you can utilize these shortcuts to make yourself, like comfortable with design and simulation as well. So let us move to this shortcuts techniques. So as you can see, if you want to open a new circuit, you can put Control N. Okay. So Control N you can put, or otherwise you can go to File and New Schematic. That will be opening a new schematic. Okay. If you have existing file, like you have already designed some circuits, then you can put Control O to open the existing circuit. So Control O for existing circuit, Control N for new circuit. Okay. If you want to place some components, you can put shortcuts like R for resistors, C for capacitor, L for inductor, V for voltage, G for ground, even D for diode. Like that you can keep on putting. Okay, so each one of the different components can be put just by pressing the keys on the keypad. That is R for resistor, C for capacitor, something like that. Okay. If you want to mirror them, like let's say you have put a resistor, then you want to put mirror it, then you can put Control E, or rotate it to Control R. You don't put just R is for resistor, and Control R for rotate. Okay, so if you want to rotate it, let's say 90, like it is like this, then if you want to rotate it, it can be like this. Okay, if you want to have a mirror, let's say diode is like this, if you want to mirror it, you can put a diode like this. So instead of rotating 2 times to get this one, just mirror it, you'll get this kind of. So this is how, like these shortcuts can make you understand. Now let us say if you want to put some components. Okay, so once you go to this component field, as I told you already, that you can go to the components. Okay, so in this component, if you want to find out like MOSFET, then you can also try by, like pausing the video and understand like how we can put P MOSFET. That is, suppose P channel MOSFET. If you want to put, you can write down here P MOS to get a P MOSFET. If you want to put a Zener diode, you can put Zener. If you want to put a current source, you can put current. So whatever the components that you want, you can put it here. Okay. So I'll also give you a, like a introduction, like how to put components again. So as you can see in very, like a simple manner, once you have to go to either components or this particular, like icon in the toolbar itself, or otherwise you can go to edit, then go to component, and this component is going to open this particular component symbol window or component libraries, and here you can write down whatever components that you want to find out. Okay, and this was actually given by Analog Devices itself. So they have given this particular slide, so, and like you can find out how to put a component and how to put your particular, like value to search a particular component. And voltage source, as I have already told you, like V for voltage source. Okay, and then you press OK, then it will place this particular component to your circuit. Okay, so all these, like shortcuts are there in only one slide. This is bit smaller. So what you can do is we can go one by one. Okay. So if you have some spice analysis, then you can go for .op for spice, like DC operating point, .transistor, .trans for transient analysis, .ac for AC analysis. So basically, while performing the simulation, you will see .trans. It means it is going to tell you that it is a transient analysis. .ac means AC analysis. .dc means DC analysis. Okay. .tf means transfer function or something like that. .noise means noise analysis. Like that, these are the shortcuts that you can understand for spice analysis. Okay. Similar to that, if you have, like a spice directive, so you have to put just S to go to a spice directive, and here you can have dot back, like annotation, annotate sub circuit, something like that. Dot ind is there, so you can read it by yourself. Lot of other things are there. Okay, so there is no need of, I mean, many of them, but mainly we will be using, like function or something like that, so that we can utilize some user defined functions. Okay, and similar to that we will be using machines. So measure. So measure and functions we'll try to utilize to make you understand like what are the things we can do. Okay, and similar to that we'll be putting ind as well. Let us talk about some other things. We have more spice directive like .NET is there. Then we have .param is there. Okay, parametric, like user defined parameters. Then we have .step, like parameter sweeping if you want. Like let's say we have to have a 1 kilo ohm, 2 kilo ohm, 3 kilo ohm together, all these three values. Or let's say you want to simulate from 1 kilo ohm to 20 kilo ohm at a step of 1 kilo ohm. Okay, so in that case, what will you do? You can write down this dot step parametric sweep analysis. Okay. So these were the different shortcuts that you can, like utilize for your spice directive. Coming back to other shortcuts, let us say how to place schematic symbols and editing modes. So this is the Windows shortcuts and this is the Mac shortcuts. Okay, Mac OS, Mac operating systems as well as Windows operating system both. Okay. So if you want to cut or delete some of the parts, then you can press, like Control X, or you can press delete. So delete button if you press, then you will get this particular symbol, so that it is going to help you to delete some of the parts from your circuits. Similar to that, you can press Control X also to do the same job of deleting or cutting the particular components. Okay. If you want to copy paste, or you want to, like duplicate some of the circuits so that you don't have to draw the circuit again, in that case, what you can do is you can press Control C or F6. Okay. Suppose you have to move some of the components. So there are two kinds of move. One is move, one is drag. So move actually will, like wires will remain there. Only components will move directly. Okay. And drag, it will get connected. It will not remove the connection. It will drag with connection as well. Okay. And suppose you have some of the like function that you are into. Let's say you are in cut mode or you are in copy mode. Then if you want to skip that, you can put escape, or otherwise you can right click, or otherwise you are placing a component, you can just right click or escape to come out of that mode. Okay. Some other parameters like waveforms. So waveforms, what you can do is you can click, then it will add a cursor or measure. Okay. And alt click, it will highlight the corresponding net on schematic. Let's say you want to see, this is my voltage value in the waveform, and I don't know which particular net this is sourcing, right? Let us say this particular green one, I don't know which one it is showing. So what will happen? Basically, you can see that if you highlight this, then basically what is telling you this one, alt click, then it will highlight that, right? So you have to do alt click, then it will highlight that particular node. Okay. So this is highlighted, your yellow color, this is highlighted. As you can see, let us say I want to put this one, alt click, then this one is highlighted, like a red color is current through R1. Okay. Good. Coming back to some more schematic, like shortcuts. So you have like alt click, then it will put a component, like plot instantaneous power across the component. We'll see about like voltage, current, and power. Okay. In the circuit, like across a component or through a component, or like around a component or at a node, what will be the voltage, what will be the current across the component, or what will be the power dissipated across the component. So these are the different, like shortcuts that we'll see one by one. Now this is going to be very very important. Just to press a like place a resistor, you have to press R. So R for resistor, C for capacitor, as we have already seen, with L for inductor, D for diode, G for ground, V for voltage source, S for operating, like or a spice directive. Okay. And if you want to put some text, like you want to have some comments, something like that, so that you can understand what is the circuit all about, so you want to write some like comments or text message about that particular circuit, so you can press T. Similar to that, if you want to like place any components, you can go ahead with F2, and for wiring you can put F3, or these are the symbols that you can utilize to place those things. Okay. If you want to label some net or net naming, you can put this particular symbol for that particular net labeling. Okay. Coming back to some more points, we have, like rotate, as I already told you, Control R for rotation and Control E for mirror image. Okay. Now, if you want to have, let's say, whatever you did the operation, you want to come back, then you can go ahead with undo. This can directly go ahead, like F9, as well as what you can do is go to edit and undo. Similar to that, redo is control Z, you can see, okay, control and high control plus above arrow plus Z, that is going to make it redo. So these are all Windows operation, and this right side is all around Mac OS operation. Okay, coming back to the numbers, or like I mean basically it is going to tell you about units. Okay, so either you can write down capital T or small t, both are going to represent as tera. Then giga is 10 to power 9, then mega is 10 to power 6. So mega you have to write down MEG, okay, not capital M, that you remember. So mega, either you write down MEG small or capital, both will have same meaning. Okay, similar to that, K for kilo, that is 10 to power 3. M, capital M or small m, both have milli. Capital U or small u, both have micro. Capital N or small n, both have nano, pico, femto, that is P and F respectively. So this is how you are going to have units in your, like a particular LTSpice schematics. So roughly, I have actually, like sorted out some of them. You can put control cut for control X or delete, copy for control C, move F7 you can do, drag F8 you can do, escape or right click, you can exit the current mode. Similar to that, you can place this particular shortcuts to like place any of the components, like R for resistor, C for capacitor, L for inductor, D for diode, G for ground, V for voltage source, S for spice directives. Okay, and similar to that, T for like text message, or like comments. If you have to put some components, then you have to press F2. Draw wire, then you can put like F3, or basically you will get like some symbol like this. So this is your pen which is going to draw the wiring, and this is going to label the net. Control R for rotate, control E for mirror. Okay, so in short, with the tools and with the like all the shortcuts, you can take a screenshot of this one. This will help you to understand what are the different tools that is used for what is the functionalities. Okay, so just now I have explained you a lot of shortcuts. We'll just see an example of each one of them very quickly in the schematic window, how to place all these particular components and how to do all these shortcuts techniques. Okay, so you can take a screenshot of this particular like a slide, and you can utilize them for your further references. Okay, so let's get into the circuit. So this is the circuit. What I'll do is I'll just open a new window. It will be easy for all of us. Now this is my new circuit. Now I am going to press R for resistor. So R coming resistor. Okay. If you have to press, like place many of them, you don't click right click, otherwise it will come out. So I'll put right click, then it will go away. Suppose I want to, like place horizontally, then I'll put control R. So control R for rotation. Okay. Control R for rotation. Okay. Let's say control R, it is coming like this. Similar to that, suppose I came out. Now I want to put capacitor. So capacitor is C. Then I want to put like diode for D. I want to put, let's say, voltage source. I want voltage is V. Then I want to put inductor, that is L. Similar to that, like I want to put ground. So ground is G. So G is for ground. So all these things are there. Otherwise, you can put from for all these components from here also. Like ground is here. Then like resistor is here. Then let's say capacitor is here, and let's say inductor is here, let's say diode is here. Okay, so like that. Okay, now let us say I want to delete all of them. So press delete button. So delete, then you will see a like scissor symbol. So you have to delete like this. Okay, delete whichever component you press, it will get deleted. Otherwise, you can go here and select this particular tool, and it will help you to delete all of them. Okay. Now going back to the like components, and here I want to like place, let's say, current source. So you have to write down current, and you will see current has been selected here. Okay, you can read complete current. So current has come. You can place like this as well. As suppose you want to place it above. So what will you do? You will control R for rotate, and it will go ahead. Okay, so like that you can place up or down, something like that. Similar to that, let's say I want to put P MOSFET. So PMOS is coming like that. You can place PMOS. Okay. Let's say you want to place NMOS, then what will you do? NMOS. Okay, so it will come NMOS. Okay. Let's say if you want to drag this, just click somewhere and you can drag left and right, not a problem. And let's say somewhere you have reached and you don't know where is your circuit complete, then place press a space bar. So once you press a space bar, everything will come in one window. So space bar, complete circuit is coming here. Okay, so let me just move up, and I'm going to place some other components. Let's say I want to place PNP transistor, PNP. Okay, so this PNP transistor is coming. Let's say I want to rotate it, control R, so it has rotated. Let's say I want to mirror it, then control E, it has been mirrored. You can see this side was emitter, now this side is emitter. Let's say I want to place NPN, so NPN has come. Okay, if you want to mirror it, I will mirror it like this, it will come like this. So hope you have a good understanding about how to place components and what are the different shortcuts that we just now we learned. And a space bar will make sure that all these components are in one window together. Okay, so good. Hope you have a good understanding about how to utilize shortcuts for different parts or different purposes. And all these things, suppose you don't have this particular tools or this particular understanding about it, here you have a edit, and in edit everything is available. Okay, so this edit will give you resistor, capacitor, inductor, diode, components, drawing a wire, labeling the nets. Let me just give you an introduction about labeling a net. Okay, so I'll just wire it like this. Now labeling a net is going to put label, so you just click here, I'll just cut it. You this is the net labeling. Okay, so labeling a net, I'll just put V in, and then V in, as soon as I place, this is coming like this. Now this particular node you can place on the wire, so place on the wire. So this has come V in. Now the advantage of this V in is going to be, let us say I want to place this particular on this particular net. So this particular voltage should come here as V in. So same way I can label this also with the same name. So if you place like this, then this V in and this V in actually is connected in the circuit. Okay, you don't have to connect up physically like this and this, they will be connected through the net name. So this is the advantage of labeling the net or naming the net names. So alright guys, if you have any doubts about complete list of shortcuts or how to use them in the circuits, then you can put down your queries in the comment box and I shall be able to answer you out. The advantage that will be using this particular shortcuts and placing the components and all the understanding about these components is you will be very familiar about this, and later on I will be utilizing in the circuit. I will not be telling all these shortcuts later on. Okay, let us say you want to place some op amps, then what you can do is put down op amp. So op amp has come, so like this op amp has come. Okay, later on I will tell you how exact part you can place on that particular thing. Like let us say this is the particular PNP, then this hand symbol, as soon as it comes, you right click, you have lot of options. If you want to define, you can define what is your VCO, what is your collector current, everything. Okay, otherwise the beauty is of this particular LTSpice, you can put a pick new transistor. So as you send, as soon as you put pick new transistor, you have lot of option of actual part number of transistors. Okay, and you can pick one of them. Okay, so this is like 40 volt capacity or 60 volt capacity, so you can place this particular transistor in your spice simulation exactly. So you have lot of option that you want to utilize for your transistor applications. Okay, so once you press OK, this particular name, let's say I will just remove here, I mean move here. So as soon as dragged here, you can see this is the part number for this particular transistor. Okay, similar to that for NPN, if I want to put the part number, you go here, you have a hand symbol here, right click, pick a new transistor, so all NPN transistor will appear and you can place any of the transistor that you want to. So let us say I want to put 40 volt capacity with this particular part number 2N3904. So the advantage of this particular transistor will be exact part number you can order in the like website, and you can have simulation also closer to the exact part. Okay, so good. Hope you have a good understanding about shortcuts that is available in this. And now onwards, I will be utilizing directly circuits, different circuits that we will be seeing. Let's say, different analysis of transient analysis or DC analysis, or like a MOSFET based circuit or transistor based circuits, or all these things one by one. Thank you so much.